Hello guys, welcome back to my YouTube channel Biomathematician. Today we will be discussing about variance. Variance is a statistical measure that quantifies the spread or dispersion of a data set around their mean. It provides a numerical value that describes the degree to which individual data points differ from the mean. Here is a formula for the variance. So for calculating a variance, we first have to find the square difference between the mean and individual data points, then calculate the sum of the square differences, and then divide it by the number of samples we have. So using this formula, we can calculate the variance. So this formula is quite similar to standard deviation, except from the fact that it doesn't have the square root. So before moving forward, we first have to create a data set. So for that, we will use NumPy. We will create 1000 data points with a standard deviation of 4 and 0 mean. So let's create the data set. Before moving forward, we first explore the data. So here's the data. This is something we have the integer value here, and this is a array. Let's check the mean of the data. So mean of the data is around 0. The standard deviation should be around 4, and the number of data points should be 1000. So we have here. So our data is good to go. So for calculating a variance, we first use a user-defined function. So we defined a function here that is called variance. So it takes the data, then find the number of observations within the data, and calculate the mean of the data, then find the square difference using this formula, and then find the sum of the square difference, and then for calculating variance, it divides the sum of square differences by the number of observations within the data, and this will return the variance. So let's check it out. So for here we can see that the variance given by this user-defined function is 15.46. So like this, we can define our own function, or we can use the existing function that is present in NumPy. For that, first we have to import NumPy, and then use var method of NumPy. So here also this gives the same result, 15.46. So you can use any of those. So let's compare the variance of two different data sets. So we have temp data here, which have the difference of 100 between each data points, and we have temp data 2, which have a difference of around 300 between each data point. So let's check the variance. So we can import the NumPy here also, but we have earlier imported it, so it is not needed to import every time. We can use it. So we can see that the variance for this data is 12,500. Let's check the variance for this data. So here we can see that it has higher variance. So we know that the difference between the data points was around 300, and here it is reflected that the variance here is 1,12,500 instead of 12,500 for this data. So like this, we can compare the variance of data to find the spread of data and the differences between the data points also. Apart from this easy to calculate, variance is very easy to calculate. Now most of the time it is used in mathematical operation in the raw form only. There are limitations to variance also. For example, it is less intuitive and it is sensitive to outliers. So less intuitive mean that the variance doesn't give the exact value that what is 15.46 respect to the data. so we don't have any idea about that. And sensitive to outliers. So if we have an outlier in our data set, so let's introduce an outlier. So we can see that the variance have been shifted little bit. So earlier it was around 15.46, now it is 15.85 by just introducing a single outlier here, that is 20. So variance is sensitive to outliers. So we can use standard deviation instead of variance. So standard deviation is most often used for practical application due to its easy interpretability and direct relationship with the user data. So for example, we have the data here uh, in uh, in a particular unit. So let's say we have a height in centimeters. So the variance will not be in the same format or same SI unit, that is height in centimeter. It can be anything. It is not intuitive, but standard deviation will always be in centimeter. So like this, most of the time is standard deviation is used, and with variance we can calculate standard deviation. So standard deviation is the square root of variance. So let's check it out. We first calculate the variance, and then for a standard deviation it will be so here we have calculated the standard deviation. So for that we first calculate the variance using the numpy var method, and then calculate the standard deviation using square root from math. So we can see that the standard deviation is around 3.93, which is around 4, and we have created the data set with standard deviation 4, which is same. So we can see that it is more intuitive as compared to variance. So most of for our practical purpose we will use standard deviation. So I will add the link for this in the GitHub link for this notebook in the description. Please find it from there.